Hello guys, welcome back to continue the solution of worksheet 9, which is talking about antiderivatives. We will continue the kind of question which included in this lesson. Here, in exercise 63 to 72, according to the exercises in your textbook, solve the differential equation. The differential equation, I told you, is the equation which has dy by dx, y prime, or f by anyway, or f prime, like this one. What is the meaning of solve differential equation? It means find the antiderivative for the given function. Find the antiderivative for the given function. Okay, by using what? Integration. By using indefinite integration. That is the operation. I use it to find the antiderivative, okay? Here, I take the antiderivative of both sides. The antiderivative of dy by dx, it means y. I remind you this one. Antiderivative dy by dx, it will be what? Y. Antiderivative of f prime x, it will be what? Fx. What is the meaning of this one? It means what is the function whose derivative give you the given function? The antiderivative of y prime, it will be y. Okay, the antiderivative of this, that is the integration of it, give you this one by using the integration. Okay, what is the antiderivative of this function? It will be what? The first derivative. The antiderivative of the second derivative, it will be the first derivative. I hope you understand this one. Okay, here, what is the antiderivative of this one? It gives you what? Y equal what? How to get the antiderivative of the right-hand side? By using what? Integration to x minus 1. Here, by the same way, for the first side, the left side, I use the integration. But to save the time, I know how to get the antiderivative without using integration, but I use also the integration. With respect to the variable of integration, which is here, that is the first step. Second step, I have to integrate. How to integrate? I remind you, in this case, I have to remember the rule of integration. The first rule, which is the power rule of integration, okay, how to integrate x to power n. I will add the exponent 1, then divide by the new exponent plus 1, c. Don't forget c because that is indefinite. As you give me value of c, I will get an antiderivative. As you see in the graph here, I have infinite number of antiderivative for the given function. That is the first rule which I use it when we integrate polynomial functions. The second one, k, the constant with respect to x, it will be kx plus c. That is the rule. Okay, here I'd like to distribute, then integrate. It will be the integration of a 2x minus 2, all with respect to what? X. Notice it is not the second step because I just simplify, because sometimes I need to prepare the function for the integration. Now use the rule of the integration. Here 2 multiply x to power 1, it will be x to power what? 2 over 2 minus 2 what? X plus c. That is called the general solution, but I like to simplify it. That's the second step, how to integrate. I integrate here. Simplify, it will be y equal x to power 2 minus 2x plus c. This is called what? General solution. General what? Solution. But means to get a specific solution, because here I give you more information. He didn't ask me to find the general solution in the question. He said solve the differential equation. But here he referred to find the specific function or a particular solution. The function, the antiderivative of the given function who is passing through the point 3 and 2. Just replace in the general solution to get the value of c. Y equal to, here 3 to power 2, it will be 9, minus 2 multiply 3, it will be 6 plus c, this 3, so is c equal negative 1. Replace by C in this general solution to get the particular what? Solution. Here, so your answer y equal x to power 2 minus 2x minus 1. That is my function which I'm talking, that is my solution which I'm talking about it. Because here is specific solution. General solution by using C, but a particular solution, I'm talking about a certain what antiderivative for the given function by giving more information. I hope it is what? Easy. Now, let's solve, I think number 63 looks like number 54. All of them, I follow the same mechanism. Okay, let's solve 63, okay? Again. Where, no, 64. 64. Okay. What is the first step? I'm sorry, what happened? Integrate both sides, or find the antiderivative of the first one and the antiderivative. I have many ways to understand. What is the antiderivative of the left-hand side, gx? How we get it? By integrate, okay? It will be the because look here, I'd like to show you how I get it, but you have to know the antiderivative of differential function. It will be the function without a derivative. Here, the integration of the first derivative x with respect to x. I give you this property before in part 1. The integration cancel the differentiation because they are inverses to each other. It will be the original function gx. I hope you understand this. That is why the antiderivative of this one, but without write this one, I understand the antiderivative of the first derivative, it will be the function, okay? Equal the antiderivative of the right-hand side. How we get the antiderivative of given function? By using the operation integration 6x to power 2 with respect to what? X. That is the first step. Take the antiderivative of both sides. The second step, integrate. Do the operation. Do the operation. Okay, which is what? How to integrate? Apply the power rule of integration. It will be the number multiply. What is the integration of this variable? Add 1 to the exponent will be 3 over 3 plus what? C. I prefer to simplify this. That is called general. That is what? General solution. But I prefer to simplify before I do the next step or follow the next step. 2x to power 3 plus what? C. But look here, to make sure your answer right or wrong, if you differentiate the general solution, if you differentiate the general solution or the antiderivative, because general solution, it means the antiderivative. If you differentiate this one, okay, this one, if you differentiate, it gives you the integrand function. 6x, that is the integrand function. Okay, clear or not? Okay, here just replace by the given point, because here, since he give me more information, I'm talking about particular solution. I'm talking about the antiderivative of the given function, which passing through by 0 and -1. Or by another way, here, if we replace x 0 here in the left side, it will be -1. If we replace in the right side 0, it will be 0 equal what? C. So C equal what? -1. Just replace in the general solution, okay, to get the particular solution. The answer which I'm asking about it, which is 2x to power 3 minus 1. That is what? Particular solution, because he gave me information, he talked about a specific antiderivative. The first step, integrate both sides, okay? Then the first side, it will be how to find the antiderivative for both sides by what? Integration. Okay, I think it's so easy and trivial for you. Okay, let's solve number what? In our live session, we solved number 65. I'll solve 65. Okay. That is the first step. I think it's so easy. Find the antiderivative of left side, which is what? HT. I have many ways to show you how we get it. If you take the integration here with respect to dt and here dt, okay? This one, the integration cancel, the differentiation, it will give you what? T. Since the integration and differentiation with the same, with respect to the same variable. Okay, what is the integration of this side? The integration of 8t to power 3 plus 5 with respect to t. Don't forget the variable of the integration. Second step, do the operation. Do what? The operation. 8, what is the integration? It will be t to power 4 over 4 plus 5, the integration of any constant, the constant multiply the variable of integration, plus c. I prefer to simplify it. Okay, 2t to power 4 plus 5t plus c. Okay, now this is called what? General solution, which had the constant of integration. Okay, third step here, how to get the particular solution. Just replace by the given information here, replace t equal 1. In the left side, it will be negative 4. Replace it t negative 4. Sorry, x equal 1. It will be 2 plus, replace t by 1. It will be 5 plus c. This one, it will be 7. Go to the other side with opposite side, negative 11 equal c. That is the value of c. Replaced in the general solution to get the particular solution. ht, that is the function. We talk about it. 2t to power 4. Replace here by the value of c. Plus 5t minus 11. That is my particular solution. This is function which I'm talking about it. I hope you understand it. So easy. Solve the rest of question as a homework. As what? As homework. Wait. Now I think this kind of question, how to solve differential equation, it's so easy. That is the last two questions which I'd like to solve. I solve number 1 and number 3, and I leave you to solve number 2 as a homework. Any question we didn't solve during the session, I leave it to solve as homework. Look here, in exercise 1 to 4, according to your textbook, verify the statement by showing that the derivative of the right side equals the integrand function of left hand side. Look here, that is what? Look, that is what? The antiderivative of the given function. That is the result. Or the right hand side, okay, it's a derivative, that is the antiderivative of this function. Okay, the integrand function, the antiderivative of integrand function. If we take, I'd like to show you that is right. Find the derivative of the antiderivative will give you what? The integrand function. Look here, find the derivative d by dx for the right hand side to x to power 3 plus c. It must be the right left hand, the integrand function in left hand side. To integrate, I need to rewrite the function d by dx. What is the rewriting of function? Right here to be in power to x to power negative 3 plus c. How to integrate, differentiate. Multiply, then subtract, decrease 1. It will be 2x to power negative 4. Okay, the differentiation of a constant, it will be 0. Okay, right in the simplest form, it will be 2 over x to power 4. I did something wrong. Yes, multiply here 6. I did something wrong. I'm sorry, because I didn't concentrate. It will be 6 over x to power 4, negative 6, negative 3 multiple negative 6. I'm sorry, yes. It is the same as the integrand function. Okay, so that is verified. You can write verified or proof. Yes, this is proof. Okay, clear or not clear? That is to check. How to check your result is right or wrong, the result of integration, or the antiderivative that you get is right. By differentiate it, it will be the integrand function. Okay, let's solve number 3. I have to differentiate the right-hand side, which is the antiderivative of the integrand. This is called integrand function. This is called antiderivative. Integrand, antiderivative. The result of integration is called the antiderivative. Okay, I differentiate. Look, I refer to the differentiation by using what? Look, f prime or dx of fx mean the differentiation, capital D, I refer to the differentiation, d by dx. By anyway, differentiate left side, it will be here, differentiation with respect to x for the left-hand side, sorry, the right-hand side, which is called antiderivative. That is the vocabulary of your lesson. How to differentiate? Multiply 3, multiply third, it will be 1. You can use your calculator, x to power 2. That differentiation, it will be negative 16. The derivative of c, any constant, it will be 0. Here, the differentiation of the antiderivative, not factorized, but the integrand function is what? Factorized. By factorizing, your answer, it will be x minus 4 multiply x plus 4. It is the same as the integrand function. So, proof. So, it is what? Proof. I hope you understand well. Thank you. Please see the video and prepare any questions that you would like to ask. Thank you. Bye-bye and have a nice day.